Today, we're diving into a world that's all around you but is completely invisible. It's a hidden reality that connects your phone, your TV remote, and even the sun itself. So let's get started with a little puzzle.
I mean, really think about it. What could your phone, a simple remote control, and a giant star like the sun possibly have in common? They seem like they're from totally different worlds, right?
Well, it turns out they all speak the exact same secret language. It's a language of invisible waves, constantly zipping through the universe, carrying energy and information everywhere they go. Now, these waves are all part of one huge family called the electromagnetic spectrum. And in this first part, we're going to break down the two key ideas you need to know to understand how this whole family is organized. It's actually pretty simple.
First up is wavelength, and honestly, it's exactly what it sounds like. It's just the length of the wave. If you measure the distance from the very top of one wave, its peak, to the top of the one right next to it, that's your wavelength. It's easiest to just think of it as the wave size.
The second big idea is frequency. So imagine you're just standing still and these waves are rushing right past you. The frequency is just how many of those complete waves pass by you every single second. And here's the crucial part. The higher the frequency, the more energy that wave is packing.
Okay, and this is where it all clicks together. This is the most important rule of the entire spectrum. Wavelength and frequency are total opposites. So if a wave has a really long, stretched out wavelength, that means fewer peaks are going to pass you each second, right? So it's got low frequency and low energy. But if a wave has a super short wavelength, all scrunched up and tight, then a ton of them are going to fly by you every second, and that means high frequency and high energy. This relationship is the key to, well, everything that's coming next.
So now that we've got our basic rules down, let's pull out our map. The whole spectrum is broken down into 7 main types of waves. And believe it or not, there's a really easy way to remember all of them in perfect order.
All right, here's the trick to remembering the order. Just say, remember my instructions visible under X-ray glasses. The first letter of each word gives you one of the 7 waves, going from the lowest energy to the highest. So we have radio, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. It's the perfect cheat sheet for the tour we're about to take.
And now for the main event. We're going to travel all the way along the spectrum, starting with those long, lazy, low-energy waves and moving up to the short, powerful, high-energy ones. And you're going to see how every single one of them plays a huge role in our world today.
We're starting our journey with radio waves. These are the absolute giants of the spectrum. They have the longest wavelengths of all. This size lets them travel really long distances and even bend around big objects, which is perfect for broadcasting your favorite radio station, controlling a toy car from across the park, and even for letting astronomers listen to signals from galaxies that are ridiculously far away.
Okay, taking a step up in energy, we get to microwaves. And yeah, they heat up your dinner, but have you ever wondered how that actually works? It's pretty wild. They make the water molecules inside your food vibrate billions of times per second, and all that friction generates the heat that cooks your food. But honestly, their biggest job is communication. Microwaves carry the signals for your phone, your Wi-Fi, and the GPS that tells you where to turn.
Next up, we arrive at infrared. The easiest way to think about infrared is as the wave of heat. Seriously, every warm object, that includes you by the way, is constantly giving off infrared waves. It's how a grill cooks your food, it's the invisible beam that your TV remote uses to change the channel, and it's what allows night vision cameras to see heat signatures in total darkness, turning the world into this incredible heat map. We've now reached a very, very special place on our map. An incredibly narrow little band called visible light. This is it. This is the one and only part of the entire vast spectrum that our human eyes can actually see. It's what gives us color, lets you take a photo, and when you focus it into a laser, it can be powerful enough for incredibly precise surgery.
So just past what we can see, we find ultraviolet or UV light. We're now crossing over into the more energetic side of the spectrum. And UV has some really surprising jobs. It's used to make those hidden security marks on money glow to spot fakes. And its energy is so potent that it can actually kill germs, which is why it's used to disinfect drinking water.
From there, we make a big jump up in energy to X-rays. Their wavelengths are so short and their energy is so high that they have a kind of superpower. They can pass right through soft things like skin, but they get stopped by dense stuff like bone. And that unique trick is what makes them perfect for spotting a broken arm or letting airport security peek inside your luggage without ever opening it.
And now, at the very end of our tour, we find the most energetic, most powerful waves of them all, gamma rays. Their power is just incredible. In medicine, doctors can aim them with pinpoint accuracy to destroy cancer cells. And that same sterilizing power is used on everything from surgical tools to food, killing off any lingering bacteria to make it last way longer.
So we've seen just how useful all these waves are. But as we've been climbing up the spectrum, the energy has been getting higher and higher and higher. And, with great power comes potential danger.
And that brings us to the serious side of things. Those high-frequency waves we just met, UV, X-rays, and gamma rays, are all so powerful that they can actually damage the DNA inside our cells. That damage can sometimes lead to cancer. It's the whole reason we wear sunscreen, to block those UV rays, and it's why doctors and technicians have to limit how much exposure they get to X-rays over time.
Okay, for our final section, let's just zoom out for a second and think about something pretty fascinating. So far, we've looked at this entire spectrum from a very human point of view. So let me ask you this. Is that tiny little sliver of visible light that our eyes can pick up the only reality out there? Is the world that you and I see the whole story?
The answer is not even close. And this is what's so amazing. Other animals on this very planet experience a completely different reality. Some snakes can literally see in infrared, which lets them hunt warm-blooded animals in pitch black. Bees and even reindeer can see in ultraviolet, following these invisible, glowing landing strips on flowers that lead them straight to their food.
And that really is the biggest takeaway of all. The electromagnetic spectrum shows us that we are all swimming in this vast ocean of invisible information, from radio signals bouncing around us to cosmic rays from deep space. And yet, our human senses are only equipped to see a single tiny drop. It makes you wonder, doesn't it? What else is out there, just beyond our sight?